Okay, greetings everybody. This is just a walkthrough of the Unit 5 practice test or the logarithms test. So let's go ahead and take care of this. Let me get this set up. First of all, rewrite it in exponential form. If all I'm going to do is rewrite that, there we go. That's a little more in focus. I start with the base. The base here is 9, and so I got 9 to the power of negative 2 equals 1 over 81. So I just kind of go in a circle. 9 to the power of negative 2 equals 1 over 81. That's it. Rewrite this in logarithmic form. I want it in logarithmic form, so I'm going to start with the log. Log, what's the base? The base is 7. Log base 7 of 7 equals 1. What's inside the log becomes out. What's inside the exponential becomes outside the log. What's outside the log becomes inside the. What's outside the exponential becomes inside the log. Okay. Now condense these things. Remember, condensing. First thing I want to do is any things here in front, like these coefficients, I'm going to bring this up in. So this is going to become the natural log of x squared plus the natural log of y to the 1/2. And then remember, I have this property which says if I have a log plus a log, I can combine the insides by multiplying. So this goes x squared y to the 1/2. Perfect. Okay, this one. Again, I'm going to bring these powers in. 2 becomes on the 5, so I get the log base a of 5 to the second plus the log base a of x to the third. That gets brought in there. Minus the log base a of y to the fourth. That gets brought in there. And I put these all together, and I get the log base a of, well, 5 squared is just 25. Let me scroll up here. 25 plus, so that's multiplied x cubed, but that minus means this is going to be divided by y to the fourth. And that's it. Cool. Okay, expand these things. Let me expand these. Expand means take this one log and make more than one out of it. Well, I've got these things are multiplied, and there's an exponent, but that exponent's only on the y cubed. So first I'm going to split this up into the log base 5 of x plus the log base 5, because like we said up above, if I have the log of something times something, I can split that up into two logs that are being added. And this goes y to the power of 3, but that 3 is going to come out here. And there it is, right? Cool. This one, these are subtracting, so this is going to end up being a log base 3 minus a log base 3. Like up above, they're being multiplied. That multiplication turns into the addition of two logs. These are being subtracted, so that's going to turn into, these are being divided, so that's going to turn into subtraction of two logs. And on top, I have x squared, so x, but the squared is going to get pulled out here in front as that 2 and 5. And neither one of these simplify, so I'm good to go. Okay, solve the logarithms. Okay, this is one of the basic equations where I have exponential equals n exponential. So I got to think here. 16. 16 is the same as 4 times 4, and 4 can break down into 2 and 2 and 2 and 2. So in other words, this 16 can break down into 2 to the power of 4 to the power of x plus 1. That equals, and 2 is prime. It doesn't break down. So 2 to the power of x plus 1. Cool. Now, since the bases are the same, I can ignore the base, and all I have is 4 times x plus 1, and I have to multiply those, equals x plus 1. So if I distribute that 4 through there, 4 times x is 4x, plus 4 times 1 is 4, and that equals x plus 1. I'm going to subtract 4 from each side. There we go. And I'll subtract x from each side. That's gone. 4x minus x is 3x, equals 1 minus 4 is negative 3. And if I divide by 3 on each side, I get x equals negative 1. Okay, so if I have an exponential equals another exponential, I'm going to rewrite these as powers of the same base, and then I'm just going to ignore the base and go from there. Okay, this is another simple logarithm. This logarithm is already isolated, so all I have to do is rewrite it. Start with the base is x to the power of 3 equals 343. Now, powers. I remember a long time ago, I undo powers with a root. So I take the cubed root. That's going to cancel. And I get x equals cubed root of 343. I think it's 7. Pretty sure it's 7. But I'm going to go to my calculator, and I'm going to do the cubed root of 343 equals 7. Sure enough, 7. X equals 7. Last thing, 7. Put it back in my log. Yep, it's okay. All I'm doing is checking to make sure it doesn't give me an extraneous answer. Next one. 30 times e to the 0.6 equals 240. This is, excuse me, this is an exponential problem. So exponentials, I solve by isolating the exponentials, and then I'm going to rewrite as a logarithm and then solve what's left. Cool. So that's not good. I just made a mess. Sorry. Okay. I'll deal with that in a moment. Okay. If I isolate this, means I need to get rid of everything outside the exponential, that 30. I'm going to divide by 30. I get e to the 0.6 equals 8. Now, it's isolated, so I'm going to rewrite it. The base is e, so that e means I'm going to take the natural log of 8 equals 0.6x. I had to put the x in. I'd forgotten it. Cool. Now, that natural log of 8 is just a number. So it's going to simplify to be just a number. So I just need to get the x by itself. I'm going to do that by dividing by 0.6. And there I get x equals natural log of 8 over 0.6. And natural log of 8 all over 0.6. And I get 3.466. And on the assignments, I had you round to the nearest decimal, thousandth. I'll probably have you do the same thing here. Cool. Now, I've got a log equals a log. To do a log equals a log, really, the logs don't matter, and all I have to do is set the insides equal. 2x minus 3 equals 3, and I add the 3 to each side. 2x equals 6. Divide by 2, and I get x equals 3. Okay, and if I put that in there, 2 times 3 is 6 minus 3. That checks out. That works great. So, there. Cool. Okay, now, last problem here on this first page. Okay, log base 2 of x plus 4 plus log base 2 of x minus 3 equals 3. I can't isolate this except by combining. If I combine this, I get the log base 2 of x plus 4 times x minus 3. Because remember, if I have a log plus a log, I combine them by multiplying the insides. Now I can rewrite this. 2 to the power of 3. 2 to the power of 3 equals x plus 4 times x minus 3, right? Cool. Solve what's left. 2 to the power of 3 is 8. This multiplied out, x times x is x squared. 4 times negative 3 makes negative 12. 4 times x makes 4x. Negative 3 times x makes negative 3x. 4x minus 3x makes a positive x. This is a quadratic. So I'm going to set it equal to 0 by subtracting 8 from each side. I get 0 equals x squared plus x minus 20. And I can factor that. 0 equals, factor it, x and x. Factors of 20 that subtract to make 1 are going to be positive 5 and negative 4. And so I end up getting x equals negative 5, because negative 5 plus 5 equals 0, and 4, because 4 minus 4 equals 0. But check this out. If I put a 4 in here, 4 minus 3 is 1. That works. 4 plus 4 is 8. That works. But if I put a negative 5 plus 4, that doesn't work because it makes a negative inside my log. I have to check my answers, and so x equals 4 is my answer because negative 5 is extraneous. Cool. Moving on. Let's look at the next page here. Okay, some story problems. Guys, a lot of you are making the story problems hard because you're trying to make it complicated. If I look at this, there's that. P equals 760 times e to the negative 0.145h. So I've got P and H. What is P? What is H? I don't know. The atmospheric pressure P So P is atmospheric pressure, okay. On a balloon, on an aircraft, air decreases with increasing weight. This pressure measured in millimeters of mercury is related to the height in kilometers. So there's my H, height in kilometers above sea level. Find the height, so I'm going to find H, of an aircraft if the atmospheric pressure is 320 millimeters of mercury. So the pressure, that's 320. So I need to go 320, because that was what they gave me for P, equals 760 e to the negative 0.145 H. That's a lot of words, but really all I cared about is, here's my formula, there's my P, there's H. What do they give me? They give me a P and they want to know H. Okay, okay. Solve. Isolate, rewrite, solve what's left, check your answer. So I need to isolate, I'll divide by 760. 760, there we go. That cancels. And I'll move over here. I'm just going to wipe the 10s out, and I get 32 over 76 equals e to the negative 0.145 H. Right? Right. It's isolated. Now I rewrite. So it's going to be the natural log. Since it's an e, the natural log of this 32 over 76. So natural log of that equals the inside. Equals negative 0.145 H. And then I just have to divide both sides by negative 0.145. Okay. I didn't bother to pick up my calculator until the very end. I guess I could have earlier and figured out what that natural log of 32 over 76 was. So I go the natural log of 32 over 76. Sorry, there's that glare. And that's all going to be over dividing by negative 0.145. Perfect. And there it is, 5.965. 5.965. So my height is 9.56 in what? Oh, kilometers. See, that's in kilometers. So my height is 9.5 something kilometers. Okay, here's this. And I just read the first word, the loudness. So loudness is L, measured in decibels of a sound of intensity. Well, the intensity is X. Measured in watts per square meter is defined as that. 10 to the negative 12 is the least intense sound a human ear can detect. That's nice. I don't really care. Determine the loudness. So I'm determining the loudness. So I'm finding L in decibels of a trumpet playing next to you if the intensity is this X equals 10 to the negative 2. Oh, I read that all the way. So they gave me this X equals 10 to the negative 2, and they asked for L. So L is equal to 10 times the log of X, which is 10 to the negative 2, all over 10 to the negative 12. Well, that's just a type it into a calculator thing. So 10 times the log, and it's a common log, of 10 to the power of negative 2, all over 10 to the power of negative 12. Is that right? Yep, that's what I have. What I have written is what I've typed in my calculator. There it is. That's better to see. Close that off. Yep, what I've written is what I've typed. And maybe that would be a little better. Yeah, now what I've written is what I've typed there. And so I hit equals and I get 100. Cool, 100. So 100 decibels. Cool. Okay, now, look at 8. The amount A that results from inverting a principal, investing a principal P invested in annual interest rate R, compounded continuous, is A equals P times E to the RT. I will give you these formulas, but you need to know how to use them. $2,000 is invested, so that's my principal, my starting amount. And 6%, that's my rate. So my rate is 0.06. Remember, change the rate to a decibel. How much is in the account after 20 years? That's a time. So A equals P, which is 2,000, times E to the R, which is 0.06 times 20. Cool. Okay, so I could type that in my calculator now. 2,000 times E, so second ln is the E, time to the power of 0.06 times 20. Yeah, what I've written is what I've typed. Cool. And I get 6,640.23 cents. There it is. Cool. How long will it take? So how long will it take? That means I'm finding a time for $25,000 to be in the account. So that's the amount in the account. So really I'm going 25,000 equals 2,000 times e to the 0.06 times t. Cool. Okay. Isolate, rewrite, solve what's left, and check my answer. So I'm going to go 2,000 divided by 2,000. And 25, I don't want to write that over again, divided by 2,000. I'm just typing that in my calculator. That gives me 12.5. So 12.5 equals e to the 0.6 t. Cool. Okay. Now I rewrite it. E is the base. So E is the base. That tells me natural log of the 12.5 equals that 0.6 t. And if I divide by 0.6 on each side, I get t equals, I don't know what that is, but I'm going to type it in my calculator. Natural log of 12.5, all divided by 0.6, and I get 4.209. So that would round to 4.210. 4.210 years. Cool. Okay. This is an interesting question. A student in Math 1, 9th grade, wants to teach about logarithms. Student already knows how exponents work. Explain what the log base 4 of 64 equals 3 means. Well, what this means, that 4 to the power of 3 is equal to 64. Remember, very beginning we said if you don't understand an exponential, rewrite it as a logarithm. Rewrite it as an exponent. Okay, logarithm always means the base to what power means the inside. So 4 to the power of 3 equals 64. Cool. But I need to see more than just rewritten there if you're going to get all those points. Put it in words. Okay, cool. Now graph this function by creating a table of values first, then plot the points of the graph. Okay, so if I'm creating a table of values, remember, I guess you could do this however, I would do this by rewriting. I'd go 3 to the power of f of x, which is your y, equals x. And I'm putting in values of fx. And I always put in just 3, -1, 0, and 1. If I put a -1 in here, 3 to the -1 is 1/3. And that gives me 1/3 -1 right there. If I put in a 0, 3 to the power of 0 is 1. If I put in a 1, 3 to the power of 1 is 3. So 3, 1 right there. Cool. That gives me enough to do my graph. If I put in a negative, if I put in a 2, that gives me a 9. So maybe 9, 2, since it gives me that many spots. And there. Now, my vertical asymptote here is at x equals 0 because it's just this line right there. The domain goes from 0 to infinity. The range goes from -infinity to infinity. The range is always -infinity to infinity. The domain is always the asymptote over. Okay, cool. Last problem here. And I've got some tech guys in here. So if you hear them, you can ignore them. Describe the transformation of this from the function below. Graph the new function. Okay, my transformation, this +2 is going to shift it up 2. That +1 is going to shift it, not right, but left 1. Cool. Well, if I do that, if I take that asymptote and I shift it up, that's not going to do anything, but left 1 will move it that way. That will be x equals -1. And if I take that whole graph and shift it that way that means my domain goes from -1 to infinity, but my range is always -infinity to infinity. So that means if I'm going to move this asymptote, because I've got to graph it, right? And then I'm going to take each one of these points and I'm going to go up 1, 2, left 1, up 1, 2, left 1, up 1, 2, left 1, and there is
Toasty in here.
my new function. That's it, guys. Okay, best of luck. See ya.